Have you ever wondered how to predict the future? Well, one way to do it is by using a statistical technique called simple linear regression. Simple linear regression is used to understand the relationship between two variables, an independent variable and a dependent variable, or you can also call them a predictor variable and an outcome variable. The strength and direction of the relationship between the two variables can be measured by the correlation coefficient, the Pearson one, you should remember, which ranges from -1 to +1. Simple linear regression helps us to draw a straight line that best fits the data points. This line is called the best fit line, or the regression line. However, you really do not want me to delve into all mathematical formulas used to calculate simple regression. You have your statistical courses for that. But rather, how do we use simple linear regression? So, for instance, we can use it in many real-world scenarios, such as predicting the price of a house based on its size or predicting the sales of a product based on its advertising budget. But what about psychological research? For instance, simple linear regression can be used to understand the relationship between two psychological variables, such as the amount of exercise a person engages in and their level of happiness. To apply simple linear regression in psychology, we first collect data on the two variables of interest, then we calculate the correlation coefficient to determine the strength and direction of the relationship between the two variables. It can be directly correlated if they're going in the same direction, or inversely correlated if they're going in the opposite directions, meaning the more of something, the less of the other. Next, we will draw the best fit line on the scatter plot using this equation, which your statistical courses will take care of teaching you. Or we just ask Jamovi to do it. We could use simple linear regression to predict a person's level of happiness based on the amount of exercise they engage in, as I said. Or we can use it to see if IQ can predict educational achievement. So, in order to test this, we will use Jamovi since it simplifies our life so much. First of all, in regression, we have two main assumptions. We have linearity and normality. So for normality, we will have to run a Shapiro-Wilk test, which can be done already in the regression here in Jamovi, whereas for the linearity, we will have to compute a scatter plot. Even though it can sound a bit menacing, it is really easy. We have to go into exploration. Here you will have scatter plot, and then you will have to put your predictor variable or your independent variable into the x-axis and your outcome or your dependent variable into the y-axis. As you can see, this is a scatter plot, and after all, we have to assume that there is a linear relationship. So by clicking linear, we can see that our data are actually approximating a linear relationship, and hence the assumption of linearity has been met. When it comes to normality and the rest of regression, we will go directly into regression and into linear regression. Now we will have to put our independent or our predictor variable into covariates and our dependent variable, well, obviously into dependent variables. Before checking the rest, we just check the assumptions, in as much as normality should be there. I guess it can be fine if it's not for many statistical courses, but in real life, normality is warranted. So, let's check Shapiro-Wilk. You will not have these ones. Shapiro-Wilk, perfect. It's above 0.05, and hence we have normality. Now, let's check the regression in general. We will have to go into model fit, in as much as we will want both f-test and adjusted r-square, or the weight of our regression. We don't need r and r-square for the purpose of simple linear regression. Adjusted r-square would be more than enough. So let's check if our model is significant. We have our f value, our degrees of freedom, and we have our p value, which in this case is less than 0.001, of course, and hence it's significant. So in the report, we will have to write our f value, put between parentheses our degrees of freedom, report the p-value, which in our case is significant, and hence the adjusted r-square, In case we would have no significance, we would not have to report the adjusted R-square, inasmuch as this would be completely useless, because everything could be due to chance if we have no significance. What is the adjusted R-square? Well, the adjusted R-square basically signifies how much of the IV accounts for the explained variability in the DV. So, in this case, IQ explains 36% of the variability in educational achievement, meaning that 36% of educational achievement can be accounted because of IQ. And this is mostly what we need for the regression model. Additionally, we could also want for standardized estimates. Jamovi already gave us t-values, which are mostly fine, which are basically signifying like the strength of the regression model, like the predictive value. However, if we want to do standardized, which is definitely the path once we will have more predictor variables, so when we will do multiple regression. In this case, we just click on model coefficients and we will check standardized estimates, which are also known as beta values. In conclusion, I've shown you how to conduct simple linear regression in Jamovi by using IQ as a predictor variable and educational achievement as an outcome variable. But this, of course, can be done for several other variables, such as time spent with your significant other and relationship satisfaction, for instance, or time spent watching TV and cholesterol levels. It can be done on any two variables. If you will have more than one predictor, as aforementioned, it will be multiple regression, but this will be the theme for another more advanced video. However, please, it's important to know that simple linear regression has its limitations. Even though we are checking for prediction, keep in mind that in correlational methods, including regression, correlation does not mean causation. So, in our example, is not that a higher IQ causes educational achievement, better educational achievement. It just says that the two are related to each other. They are following a similar trend, which there might be some sort of causation, but it cannot be implied whatsoever without the use of experimental methods, such as, for instance, t-test, as we saw in the other video. Nevertheless, I hope that this was an educational enough video, and I will see you in the next one. So keep practicing, keep learning, and keep improving your statistical skills.